Maybe let's start the presentation now because we are in Feb 2026 and AI is just no longer the trend. I think we work AI in our daily life now. Let's walk through the AI architecture landscape. I think most of you are already aware about this architecture. Maybe let me clarify the relationship between the AI, machine learning, deep learning, and the generative model. So AI is basically enable the system to simulate decision-making, reasoning, and the automation at the scale. Then machine learning allow the system to improve accuracy and detect the pattern without manual rules creation. Then third one is the natural network. So it's a kind of machine learning model, which basically, it's a kind of woman brain and made the layer of the interconnected nodes. The next one is the deep learning, where our generative AI is built actually. So it's a natural network with the many layers that automatically learn the complex feature. And the main topic is the generative AI. So generative AI is the model where creating a new content like a text, images, or the video from the learned pattern. And it basically transforming productivity and the automation. The main in generative model, there are two main part. One is the LLM, the large language model, and second one is the diffusion model. Large language model is just generate the text, and diffusion model generate the images and the video. Then, as I mentioned, what is a large language model? So large language model is the deep learning model trained on the vast amount of the text and understanding and generate the woman language, include the text, code, and the conversation. Maybe let me just brief you about how exactly it's built. It's just a high-level understanding. First, it collects the massive amount of data. Maybe the data is available publicly, or it's a licensed data, and it's a woman-created text. Then they train the model. So training with the thousands of high-end GPU and cost tons of millions of dollars. Then third is the basically knowledge. Once training is completed, model knowledge is frozen. It only knows the information up to its training cutoff date. It does not automatically update itself and the new and the recent event, or maybe our enterprise data as well, because they don't have any access for our enterprise data. This means the model does not automatically know anything. But with the external source, we can attach with the model like a rack solution, which I will explain in next slide. We can train or we can fine-tune that model. And last one, finally, model is deployed to the user after its release. But the important part, the parameters remain fixed. So many people will ask, then why we can't just retrain this model weekly? As I mentioned in the second part, the train model. So full LLM training, it's required the massive compute, time, and the cost. Because retraining is expensive, slow, and the model, that is the reason model is rely on fine-tuning and the external data source for the update. And one part is very important to remember in this LLM model, is LLM is generate based on the statistical pattern. It's not on the true understanding base. It just create a content, generate, or it's based on just token. It's just pattern-based token. It just provide you the correct answer. Then next part is basically limitations of the LLM and how RAG, basically, anyone know about what is the RAG? So that's a limitation with the LLM because as I mentioned, LLM having one cutoff date. Then after, they don't have access any of the data, any of the live event. And like your company information, if you want to use your company information, you will not go ahead and upload your company data to this publicly available LLM model. So that is the reason RAG come into the picture. Maybe before that, let's understand the limitations of the LLM. First one, I already mentioned, is the static knowledge because training date has training data has the cutoff date and there is no real-time data after that. Then the privacy security, I mentioned already, we can't able to upload our company data or the company confidential document to the public LLM. Then next one, hallucination. It's, I think, the common pattern with the all LLM model, because LLM, it's a predict next token, and if they can't generate the right answer, they confidently give you the false answer as well. So that's an important part. The LLM generate response based on the statistical pattern, basically token as a, basically it's a token, predict the token based pattern. Then next one is the context and the memory. As he mentioned, his context window got full after the 4 hours. That's a major problem with the LLM. It's a limited context window. And next one is the prompt. It's very important what prompt you give to the LLM, because generally output changes based on how you phrase the question. Sometimes you provide the prompt, but LLM think in a different way, and they give you the different answer, which answer is not relevant to your requirement. So this thing, it's definitely happened with the LLM multiple times. So to overcome this all limitation, the RAG come into the picture. So RAG, basically, they provide a static knowledge. It's the fresh document query. Basically, you can upload your own company data to the we can store this into the local storage account, or we can store it on the cloud, and we give the access to the LLM to access that data. Then we have a privacy and security, because it's a retrieval your internal source from your own database. Then hallucination, basically the grounded in the real document, so there is a less chance to hallucinate, and it give you the little bit better response on your company documentation. Then next one is the context and the memory. It's inject relevant chunks into the every prompt, and the prompt sensitivity is a structure system prompt plus a retriever context. And key point to remember here, why AI agent come into the picture? Because again, this RAG provide you only the knowledge. It's just a reading, but it can't perform any actions. So that is a reason, it's just a passive system. So that is the reason agent come into the picture. Agent take this further and perform the action. Whatever boundaries or whatever rules we will set, agent act accordingly. Then next one, what is the AI agent? I think it's a main topic for the today's presentation. So an AI agent is the software system that uses LLM for the reasoning and integrate with the tools, memory, and planning to achieve the goal autonomously within the defined boundary, because this word is very important, within the defined boundary. I will explain that in later part, but this is a very important word. So what agent is doing? Agent is equal to LLM. Your LLM is basically the brain for the agent. It's understand the user request, think through the problem, and suggest the next step. Then the tools. So with AI agent, we can attach the different tools, like a web search tools or the MCP. I think most of people heard about MCP server, because I think it's pretty trending nowadays. Then the MCP, then the API, and the database, and the code execution. These are the different tools which can attach with the AI agent. Then agent will plan the stuff. So break down the complex task, break down the complex goal into the step, and decide which tools you use, and adopt based on the result. And last part is the memory, because memory it's needed so agent don't forget what exactly he is doing and where it's stored. So there is basically two kinds of memory. One is the short-term memory. Short-term memory store into the conversation itself. And second one is the long-term memory. Long-term memory you can store into the any kind of database. Maybe it's a SQL database or non-SQL database, it doesn't matter, but you can store this anywhere on your cloud. So it's a basically React loop, which I mentioned. So agent will reason, act, observe, and the repeat, and deliver the answer to the user. Then there are different types of agent. One is the task-specific agent, where in a task-specific agent, basically, it's operate within a single domain. It has clearly defined tools and the boundaries. Tools which I mentioned, boundary means what kind of the rules and the error handler we set inside to the agent will just act accordingly. So it's clearly defined tools and the boundaries, and it execute within the fixed scope. So if I want to give the example, even we also built one GitHub action agent where only one agent work to check the flow. If the trigger got failed, it's automatically pop up and it fix your pipeline. So this is only one single agent who perform all the tasks, and it's a task specific agent. Then second one is the workflow agent, which is basically, you can say the second, it's basically this goes beyond the single task. It orchestrates the multi-step pipeline and manage end-to-end application flow. It can plan the sequence action, handle the retry, and manage the error across the step. For this example, the best example is your agentic deployment, your end-to-end deployment. Anyone use the NA10? Yeah, it's not a multi-agent, but definitely we use the AI agent to completely automated our workflow. But it's just not restrict with one single application. It's a multiple application, it's work together. So that is the reason it's a part of your workflow agent. Then the last one is the multi-agent system. It's pretty advanced stage, I must say. It's about that you can say it's the most advanced form of the multi-agent, multi-AI system. So here is the multiple specialized agent collaborate together to achieve one certain actions. In that, you can say one planner agent decide what to do. Second one worker agent execute a task, and a validator agent check the result. And they share memory as well. So this is a pretty advanced agent in that you definitely configure a lot of rules, a lot of error handler in each and every agent perspective. And you need to combine them together as a single agent. But each agent perform the different task. Whatever rules we are set to that agent, he just perform that kind of the task. So these are the three main agent type. There are multiple other agents, but these are the three main agent type. And here is the important part to understand. This is not completely autonomous. It's simply more capable and the structure. Why I'm saying it is not completely autonomous? Because every time I'm mentioning that we need to set a rules and we need to decide the boundaries for the agent. So agent will definitely use his brain, but whatever rules and the boundaries we set, he just act accordingly. And that's a very important point to understand. Then next part it's okay, AI agent. The next part is the agentic deployment. So agentic deployment refer to deploy system where AI agent operate autonomously within defined boundaries. It's very important word, within the defined boundaries which developer set in the environment to complete the task and the orchestrate the workflow. So this is where become, I think, the more practical. So in this whole diagram, it's not a diagram, it's just a little bit structure which I prepared. Its agentic deployment refer to deploying system where AI agent operate autonomously within defined boundaries and the environment to complete the task and the orchestrate the workflow. So basically, sorry, 1 minute, yeah. So here, the user trigger a request, the agent will reason, plan, call the tools, and access the knowledge, and use the memory and deliver the result. But very important point here in the last, I think, the RBAC. So, but everything is happened within the RBAC, policy, logging, and the audit. So agent run with least privilege access using the managed identity, RBAC, and all secrets and keys are securely stored into the key vault. So there is no hardcode API secrets or exports. So in this whole architecture, if you see, first user trigger the flow, maybe user trigger any action. There is an orchestrator layer where we define set of rules and the policies. Then an agent will use the rack, which I explained. Then the different tools. Tools maybe you can use the MCP or maybe the API, the database, any kind of tools or your own database as well. And last part is the memory. And then it combined together, an agent will provide you the response. So it's a overall agentic deployment workflow to integrating your agent in your actual environment. Then the next is the market reality, because I think it's very important to check, to quick reality check. There is a lot of hype around that fully autonomous AI agent, but in enterprise level, that's not actually happening. Agent is not fully autonomous. I mentioned this multiple times because it's very important to understand the boundaries of the agent. What agent can do? Agent can basically reason about the task using LLM intelligence. It can be planned multi-step workflow. It can be called the tools, API, and the external service, handle the error and the retry and the self-correct that, and it's maintain the context across the conversation. But agent can't do. It's a define their own goals and the objectives, access the tool you haven't configured, then override the security policy, and operate without a woman-defined boundary. So it's very important to understand here, agent will only perform the task which you define to them. Like I will take the example of the GitHub workflow. So I set up the agent, and the suppose GitHub workflow pipeline got failed. But the rules, suppose GitHub workflow pipeline failed due to maybe Docker credential mismatch. Okay, we just take the example. But that rule, if it is not defined into that rules, then agent will never auto-fix that part. So this is very important thing to understand. So if you want your agent actually work into your environment, each and every time you need to define the rules and the error handler. So error handler basically what exactly agent needs to achieve. So this reality check is very important, that agent just provide you the intelligent orchestrator for the reasoning, but you define the execution logic and the boundaries. And this is the market research. As per the market, you can say the 60% of organization experimenting the AI agent, and 23 is already scaling that part. The 40% of the enterprise application are still using the task-specific agent, which I explained. It's a very basic level of agent. Then 75% are the prioritized. They are more prioritizing of the security, compliance is the number one requirement while deploying the AI agent. And it's a basically multi-agent orchestrator, and MCP become the standard nowadays. So in 2026, the main pattern is that first one is the LLM reasoning, then you can integrate a RAG, then you can orchestrate the tools. You can use the different tools like a MCP or maybe your APIs, then your database, then you can create the multi-agent on top of that, and overall the whole package, the important part is the strict security and the boundaries of that agent. Then I prepare one small demo. So this is currently, you can say, the testing phase portal which we created. So in the whole basically agent, this solution is enable control by the one-click infrastructure application deployment using the agent-driven orchestrator workflow. When the user click to create a web app, by internally, basically the backend API will trigger where I configure the rules and the error handler, and the agent will evaluate the predefined rules, and the environment will configure automatically with the help of the Azure SDK and the Terraform. So maybe first let me show you the demo. See, here I click this is our portal. This is a test portal at this moment because we're trying to experimenting the different use case with this workflow. So it click, maybe let me go a little bit far. So it's deploying for storage account. Yeah, the storage account is created. Maybe see, this is my agent. I can see the logs as well. So this is whole infrastructure is created by the agent. Okay, the same way the web application, I just define the rules and I just define the Terraform configuration inside the agent, that's it. And there is a backend orchestrator layer where it integrates everything together. Yeah, it's deploy now, and even we created the custom deployment option as well, where you can choose the region, you can select your own name as well. Yeah, see, web application is also deploy. Now I will deploy the virtual machine. In virtual machine, you know that there are a lot of different parameters are there, but everything is managed by everything is created by the agent itself. Yeah, see, the virtual machine is as well is created. It's a web app. Yeah, it's virtual machine is created. And you can see the logs, everything, because this whole step performed by the agent on its own, and it's deploy your virtual machine. So that's a main key takeaway from this whole lesson, that LLM are powerful, but it's incomplete alone. They are frozen model, and they need a RAG for the knowledge and the tools for the action. Second one, RAG makes the AI enterprise-ready application. Its ground respond in internal data without retraining the model. Then agent move from the answer to action. By combination of the reasoning tools and the memory, agent enable the real task executions. And important, the enterprise AI success, it's all depend on what architecture you are created. End of that, it's all matter what security is there inside that agent, what rules or what error handler you define while configuring the agent. And very important, agent is not fully autonomous. It's definitely use the LLM as a brain, but it react on what kind of the rules you set during the configuring the agent. Maybe, yeah, that's it.